One thing that is important to mention is some of those packages require a recent version of R. So if you have like an old installation of R, it may be necessary to update or upgrade to the latest version. So you can install all packages without any problem. Some of you may see a message asking if you want to update any package. In order to avoid any conflict or any issues, we recommend it that you update those packages. So the polymapper and map-poly will work without any problem. There's a question here. Could you help with polyorigin in Julia? How to install or run it? Yeah, we will cover this. We will just demonstrate how to install the two R packages before, because they are pretty easy to do, and then we move to Julia. Okay, so yeah, in the meanwhile, I will show how to install Julia. Okay, so when you access the link on our Polyploid website, there is a link to Julia. You can access this link and you'll find the different files that you need to, in order to install in the different operating system. For Windows, for example, you have an installer on the .exe file. On the Mac OS, I don't have experience, but it probably is the same as Windows, like one file that you need to download and install it. And the Linux, we found that it is a little bit tricky. So you need to, first of all, you need to download the file, and save it whenever you want. Okay, you replace it. There is another link I can share with you that describes with more details. So this is a link where you can find the description on how to install it in Linux. So I will switch to a terminal right now. Okay, so in the terminal, you need to navigate to the folder where you downloaded the Julia. You need to uncompress it with this command. Then you move this folder to the OPT, which is the installation directory under Linux. Then you need to create a symbolic link of this folder, Julia. To the current user installation one. Okay, so I have done this before, but it should work without problems. In that, you can just go whenever you want and run Julia. Here it is. In order to install polyorigin, you need to first type in the closing bracket. Then you need to add the repository. I will send on the chat. Okay. Okay, so I had it installed before. It should take some minutes until you install if it is the first time. After that, you need to Control C, then using poly origin should work. Cesar, I see your message. You have this error because you need to press the closing bracket. I don't know how to show this. You need to type in this character that I'm pressing here. You type in once, then you put your command. Okay. So I will return and just check if it's working. Cesar, tell us if you could make it work, please.
Where does the bracket go? It goes before the add?
Yes, before the add. You know, when you type this inside Julia, it changes the prompt. Look here, I press right now, so it changes to package, you know. Then you type in add. You're welcome. Okay, so when you press, it changes the prompt. Then we can just ask for help on poly origin and see if it is installed. Okay, poly origin is a package for haplotype reconstruction, so it's working. Sadly, you need to type add before the link to the GitHub repository. Okay, this is the reason you see this error. You need to type in, like, you type the closing bracket and then add, then your link, https. Okay.
Caesar still run into the same problem. He needs to do the closing bracket not as part of the pasting in. So closing bracket gets you into like another mode so that you can install. So don't use it as, don't include it in the copied.
Yes, great, Jigging. So yeah, I don't know. I'll just show it again. What Jigging says is that you need to type in you don't need to paste. Okay, you just type this, then you paste just only the add.
Then you paste the other thing. Yeah.
Yeah.
Then paste add GitHub, whatever.
Yeah, this one, right?
Yep. Yep. And your console should turn blue to PKG, like what he was showing.
Mm-hmm. Yes, Cesar. Yes, that's correct.
Yeah. Luckily, this is the most confusing one.
Yes.
If we can get this one installed, the other ones are super easy.
Yes. Yeah, that's true, Jigging. You know, I stayed for some time without working with poly origin, so these days I tried to install and I found the same error I was trying to paste with the command. Okay, great, it's working. Cesar, could you solve this? Could you install the package? Okay, so I will leave this open here. If someone needs any demonstration again, or if you are facing any error messages. Okay, the installation is in 50. Okay, so yeah, it's working.
It's working.
It seems to be working. Yeah. So yeah, it's a great idea. So we can include these steps in the recommendations. Yeah, this will make things easier. Okay, so I leave this open. I will switch back to the R Studio. So I will just run the command to install mappoly now, but it's pretty the same as for the polymapper. I send you the command. In the chat. While the package installs, I think it's good to mention that mappoly has a development version on GitHub, and you can also you have the choice to install the package directly from GitHub by using DevTools. But it's important to mention that if you are on a Windows machine, you may need to install RTools before trying to install this directly from GitHub, because it will try to compile everything on your machine. So you may need to install the RTools before installing the DevTools package. Okay. I don't know if you have anything to add, Jigging, Chris, Maria, but I think this is.
Somebody asked an interesting question. Richa, I don't know if I'm saying that right, says, hi, should we install all of the software for a linkage analysis? I am familiar with R, but not with Julia. I just installed Polymapper. So I can kind of answer that question. So each program has its own pros and cons. So for the one in Julia, PolyOrigin, that comes in handy if you have interconnected populations that are sharing parents, and that you want more power from your later on QTL analysis from those shared parents. But if you're just doing, and actually PolyOrigin doesn't do linkage mapping. It just does, it just figures out the parental haplotypes and which order they go in. And while Polymapper and MapPoly are the ones that actually do linkage mapping. Yeah, I don't know if that answers the question. So you don't have to install all of them. You kind of just pick and choose and see what happens.
Maybe I can add to that. So if you use PolyOrigin for haplotype reconstruction, just like Jenkins said, is because you're taking the advantage of having interconnected populations, but eventually the output from PolyOrigin will be used in other software such as DiaQTL. So if you want to do for the next session the QTL mapping using DiaQTL, you will need the output from PolyOrigin. So I think once you get it to run, it's pretty straightforward. So it's definitely valuable. But yeah, if you're here, it's because you want to get this sorted out. But other softwares will use the output from here.
Just one thing that I received here in the chat. I don't think it's visible to everyone, but there was someone with an error installing the PolyOrigin. The error is that if you need to type in the address to get the GitHub repository exactly the way it shows on the command line here. Okay, so if there's any space, any point, any dash, anything additional, it won't work. It needs to be exactly the way we pasted on the chat, or the way you find in the repository. Okay. Yeah. Okay. So it finished the installation of MapPoly. So both MapPoly and Polymapper will install directly from R with just one command, like install package codes and the name of the package. Okay, here you go. It's working. So if you have any question, Any other question, please go ahead and open your microphone or send us in the chat or on the Slack channel. I stop sharing my screen, then go back to the presentation. No, I think, yeah, I think we covered the three softwares. So we are now open for any questions you might have. Please go ahead and open your microphone. Okay, Richa. You are having troubles downloading Julia. So which operating system are you using, Richa?
So I'm actually working on PC, so I guess the link that you sent is not like opening.
Okay, so let me
The
send you. Yeah,
yeah.
I send you the link directly on the chat, so you can just click on it.
Okay.
Can you see it?
Yes. Thank you.
Okay, you're welcome.
Okay, here. Can y'all see this?
Yes.
Okay, so she's having a problem with clustering in Polymapper, and how many chromosomes is in your species?
So in total, so that's these 32 groups of homologs that I expect. So and that's 8 chromosomes is what I expect.
So I'm not seeing very much structure at all.
No.
To this.
Yeah, and this is actually yeah. So before this, so yeah, what I've done is just sort of the sort of standard quality control steps, and those looked all okay. And then in the initial clustering, I was still getting a lot of clusters that only had a few markers in them. So then I basically deleted, I just removed these at like these based on different a different LOD thresholds. I selected all of them, the groups that had few markers, and I removed all of those. So that is then the result of this. But I still had difficulties then deciding, okay, how am I going to assign these 8 chromosomes and the 4 respective homologs for each of these chromosomes.
Okay. I'm trying to think. Did you do any of, so in the filtering steps, you know how you can do the F1 segregation distortion kind of stuff?
Yes, I did some checks there. Yeah.
Did you, what kind of, I guess, what kind of filtering did you do on that? Because it has multiple checks in it.
Yeah, I need to open the script I was using, but what I recall, so there's this 3 different quality parameters, if I recall correctly. Initially, indeed, I just selected on like the Q all, where
that's what I did.
Yeah, but I tried also being a bit more stringent by selecting also each of the individual parameters.
Okay.
So I played around with that a little bit, but each time I changed something, it's still eventually this was sort of the best result that I got. So let's see. I'll just open my scripts so that's when I can check exactly what I've done. No, but I'm aware of this segregation step. To check that. But,
and did you, when you're doing clustering, I don't know if you know that there's a function that you can actually display how many markers are in each group.
Yeah.
Yeah, that's also helpful. And it kind of, let me see if I can share.
Is it a similar clustering plot, but then with the numbers in, I guess?
Yeah, except with the numbers, Yeah. So that's how you used to throw out the ones that only had 1 or 2, correct?
Yeah. That's correct.
And did you do the step that they kind of a QC step with the PCA, just to see if?
Yes, and there this, yeah, I couldn't throw out any, so I have to check, I can't quite recall if it's just for the individuals. What I've tried to do is, sorry, I've done this, like, I've worked a little bit on this like a month ago and I couldn't get forward, and then other things went in between, so not entirely, yeah, I can't remember everything completely, but basically what I've tried to do and was quite successful is basically be quite stringent with the SNP filtering, but then still try to keep as many individuals in as possible, because the population that I'm using is not so large. Yeah, and what
does your species have a genome?
No, not yet.
Okay.
Oh, yeah, but well, it might come available at some point. So that's why I also asked, like, oh, would it be possible if this would come available to, yeah, that was also one of the things I was thinking of now, because, well, I'm having difficulties with this last clustering step. What information I got so far was at least, well, I know now because we have some markers of interest, and I know, oh, they are located in like in a similar cluster, or they are located in different clusters. So that already gave some information for now. But indeed, we're hoping to get a genome reference soon. So I was just wondering about the options in Polymapper as well, how to
so Polymapper,
those, yeah, based on the genome positions, basically.
as of now, Polymapper, I don't believe has a way to incorporate like a genome position and to cluster by that. MapPoly can. So MapPoly, you can kind of say, okay, I know that these markers belong to this group, these markers belong to this group.
Yeah.
And then you just group them that way instead of looking at recombination fractions and grouping them by LOD. And then you just order the map, either using MDS or using the HMM chain. And that's a possibility once you get if you get a reference genome. But otherwise, Polymap, if you're just going to have to throw away groups and stuff like that in Polymapper, you have to do it very, I guess, you have to do it by hand, if that makes sense.
Yeah.
Because for me, one of my populations that I mapped was kind of, both of them were pretty clean, but they wouldn't break off that one lot. So you would have to go in there and export out the files and kind of manipulate and say, oh, I know this one belongs with this one belongs with this one, and then load it back in and trick the program to think it's cutting off at that lot.
Yeah.
If that makes sense. And I can kind of share a screen to show you what I mean by that. And I don't know if that might help you later on.
Yeah.
When you get to that step.
So do you, sorry, yeah, maybe if you could show, do you also have an example of how you do this reordering based on genome positions, for example? Like how do you, so do you just export the clusters from Polymapper and then reassign them in some way, and then
so once you get a genome, you could just basically either your input files for MapPoly would have a column for chromosome and a column for position, and then from that you have like different ways of how you can cluster. You can either cluster based off of the physical order, or the physical, whichever chromosome is placed on. You can kind of try to group them by the recombination fraction, and they use UPGMA clustering, or you could do an intersect of those two, which is the most conservative. But if you just wanted to get a map to work with and your reference genome is pretty good, you could just say, okay, I just want all the markers that belong to chromosome 1, 2, 3, 4, 5, just the way it is in the physical order of the reference genome, and then just let the map run. So you may, if you have a reference genome, you may not even need to cluster. The clustering is basically what chromosome it's assigned to, that marker is assigned to.
Yeah,
And
then
is
you just filter out the ones that are informative then for your population.
And is your stuff GBS or is it what kind of markers?
Yeah, it's GBS data.
Okay.
Oh, sorry, no, it's So it's I have two different populations. I have partly GBS, but I also have some array data.
Okay.
So
it's
that array
partly
data
GBS, partly array.
Yeah, and array is what I've mainly used now because it's I found it a little bit easier for the filtering already.
Yeah, it's a little cleaner.
Yeah, so I thought let's start out with that. Yeah, okay.
So, all right. So here's an example where you can't take so I have 7 chromosomes, right, and 4 homologs each. And I can't take any lot. I can't say, okay, lot 3.7 right here, is that would give me on the chromosome level, it'd be 1, 2, 3, 4, 5, 6, 7, 8. But I know this is a chromosome, 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 this one, this one. So you can take the object that comes out of this and basically rename these to be one chromosome, if that makes any sense. You can manually like mess with the groupings, but you have to export a CSV file, manipulate it in Excel or something, and then throw it back in and tell it, okay, these belong to these groups.
Okay.
So when you get to that step, you could probably do that, and you could send me an email, and I could help you out with that once you get to that step.
Yeah, I just need to. I didn't realize you could also provide positional information because now I just read in a genotype file, but I need to check how to.
In Polymapper, you can't really provide a genome position. It just doesn't really. But in MapPoly, you can.
Okay. Yeah.
Let me see. How do I? So I don't know if that kind of answers your question. It may just be a thing of where you just have to play around with the data more. But I will send.
Jigging.
Yes.
Maybe you can talk to her a little bit about also making sure that all of the members of the population are actually bona fide crosses or products of crosses. I know you talked about the PCA. That's important because if you have individuals that are selves or mix-ups, then of course that's going to interfere with the quality of the map down the line. And maybe you can talk a little bit about how you do some QC on the marker set as well.
Okay. So I ran into a similar problem, and I don't know. I guess this is pretty. You can kind of see this. So I had two main populations, and the one in red and the one in black. But whenever I was trying to map, and one of the maps just wasn't working, and finally I was like, okay, I should have done this as a first step, but I ran a PCA to see if, hey, are these individuals actually what they should belong to? And what happened was that there was a third population up here that belonged down to here, but I was acting as if they belonged in here. But if you have 15 or more, this is actually like 16 individuals. If you try to map with those individuals, your groups aren't going to fall out how they should fall out. So kind of before you do all your marker filtering and stuff, you could just run a rough PCA. If you only have one population, what you should see is basically a cloud of individuals and your parents kind of close to the middle. If the cloud is in the middle and the parents are way outside, then maybe something is wrong, but it should be the parents pretty close to the middle, and then a cloud of the individuals. And you shouldn't see any groups that are by themselves. If there are groups by themselves, then maybe that's a problem. And that's a built-in function in Polymapper. I think it's called Pca Progeny. And you can highlight the P1 and P2 just to see where they are. Highlight it with red. I think that's in their tutorial. But yeah, I think that is in their vignette. And just to see if you did all these steps, you probably did, because you probably just follow the vignette.
Yeah, I just have like a whole PowerPoint slide with all of just a whole PowerPoint document with all of the different steps.
Yeah, you did this step, right? The check one.
Yes. Yeah.
And then you did the same thing as me. You basically just filtered for everything that's, you removed all the ones that had,
Mm-hmm.
you use Q alt as the,
Yeah,
as the thing. What kind of missing data cutoff did you use? This.
0. Actually, maybe I don't know if it's strange or not, but 0.1. It's a cutoff that I've used.
0.1
Yeah, because
for progeny. What about for markers?
For markers, this is
Markers also. So
sorry.
that's one thing I found. So for, sorry, go ahead.
No, sorry, I was referring to the wrong cutoff. I need to check. What's the function called again? Then I'll just.
It was called.
Mark data summary.
I think so.
Also 0.1 here as well.
Okay, and then what about for screen and A values?
Screen. Also 0.1.
Okay, so that might be a problem. So I was
Okay.
getting very messy stuff with yours,
Yeah.
but with my data, it kind of looked like yours. I didn't see very good groups because I had too much missing data.
Right.
So how many markers are you working with?
A little bit. So the snapshot is a bit more than 27K. 27,000.
20, and how many individuals do you have?
Let's see. 225. And there are
Oh, that's a pretty good population. Yeah, that's a good size population.
Yeah.
So you 225 in a tetraploid. I mean, you're going to need in the end, right? What because we know that recombination events, it's probably like 1 per chromosome per individual, right?
Yeah.
So you only really need 200-300 markers on a chromosome that's evenly spaced throughout the genome for your QTL scans in the end. So you don't really need 27,000 markers, correct?
No, so basically after all the filtering, I went down to like I went down to 2,000. So
2,000?
Yeah.
Hmm.
Maybe that's.
Let me see how many I had. I think I ended up with like 5,000 to start with, but this step is what happened for me. These two steps, I was really stringent here.
Okay.
So screening for individuals with missing data, and for here. My bad. This is this less than 1% missing data on NA.
Oh yeah.
So try to play around with that and not use 10%. Because that allows a lot of, and when I started playing with screen for NA and the one for individuals, the one where you filter based off individuals, I started seeing the groups falling out differently.
Okay.
So kind of play around that, see if you start seeing your 8 groups show up or whatever.
So sorry, the function for the individuals, which one is that? Is that this
I
marker
think
data?
it was this one.
Just the marker data summary. Here select 0 point. Oh, okay.
I think so, but I'll have to send you a follow-up email to kind of tell you what the problems I was running into. Because now that you said your cutoffs were 0.1, that I saw the same thing. Because I wanted to keep as many markers in the beginning also, but because you're using array data, it's already supposed to be pretty good. So you can kind of just throw out the junk and just try to keep the really good markers is what I found. But yeah, I'll send you a follow-up email telling you which two things I've manipulated to kind of get my groups to fall out.
Yeah, and then eventually, when you have your groups falling out, you export it, and then maybe say
I would
like, okay,
export the groups,
yeah,
and kind of make my cutoffs and just trick Polymapper into thinking I'm using one cutoff for the chromosome and one cutoff for the homolog, but it's really not clustering that way. So you can kind of manipulate it to do that. But yeah.
Yeah, just one thing that I was going to say, that Risha sent a message asking for help with PolyOrigin installation, but it seems that everything worked now. Yeah.
I just wanted to mention that once you have Julia installed on your computer, that's all you will need to run in Julia, because there is a wrapper for PolyOrigin, and you can do it in R. I think maybe Gabriel already mentioned that, but it won't be that you need to learn to write a new language to do the haplotype reconstruction.
Do you mean like people can make use of that R wrapper, right? Okay.
So I guess following with some of the questions that we have here, I don't know. I know that Jigging has worked with this, but maybe some people are wondering which are the main differences between each of the softwares that you're using for this session.
The main difference between the software. So I've used all three, and the main, I guess I would say PolyOrigin is by itself. It's not really for linkage mapping. It's for like Maria was saying, haplotype reconstruction of the parents, well, of the parental haplotypes, and it's for interconnected populations, and it's for use with .qtl later on. And I guess Polymapper, we'll have a session in the Polyploid meeting in January where I'm supposed to kind of compare MapPoly and Polymapper and the pros and cons of each. But I guess in short, Polymapper is, I feel like, more, you can manipulate it more. There's little steps that you can kind of trick the program into thinking such things. MapPoly is more automatic. You just give it everything and it just goes. And I'm trying to think, the computational needs. So Polymapper doesn't need as much computational resources as MapPoly. As of right now, new versions are being developed. Gabriel's working on that to make it more computationally efficient. But say if you're only working on a laptop, maybe 16 gigs of RAM, you would most likely only be able to run Polymapper. If you have access to a workstation, like in our lab, we have a workstation that has 48 cores and 256 gigs of RAM, then you can use MapPoly. And the main difference of why the computational resources are so much is MapPoly does its recombination fraction estimates in kind of two steps, where first it estimates the recombination fractions between all the simplex and nullplex markers to make a scaffold. And then it calculates all the other types of markers against that scaffold and tries to fit those markers. And MapPoly takes another approach where it just estimates the recombination fractions of all the marker types together first. And Gabriel, I've seen the new function, and he's gotten that down to be a lot more computationally feasible for someone with a laptop to run. But the main difference is the recombination fraction matrix estimating portion is MapPoly using all the markers, and Polymapper only uses simplex by nullplex markers first. So it breaks it up into two, whereas MapPoly does it all at once. And then the difference is in making a map is that Polymapper can only order your map using MDS, and Map Poly can use MDS, and it can use the physical genome order to run the HMM chain. So the Map Poly it requires that a priori ordering of the markers to run the chain. And the two possibilities as input there is an MDS order or a physical map order. And so, yeah, those are, I think, the main differences between those two software. And luckily, the group in Wageningen and the group in North Carolina have been talking, and they have functions to go back and forth. So for me personally, back when I was making maps 3 years ago, Map Poly wasn't like that popular, I guess. I don't know. It was being written, it was in beginning stages, and Polymapper was one of the first ones. So I mapped my maps in Polymapper. But I wanted to do my QTL stuff, what we'll talk about next week, in QTL Poly, because at that time, QTL Poly R wasn't released yet. So luckily, these guys all talk to each other and have functions to go from one phased map to another phased map and go in between the programs. So luckily, that's been a thing. And trying to think what else.
You want to make a quick comment about the quality of the maps that come out from both software and whether they're comparable?
So I have run both maps in both, and it seems like Map Poly's map length is a little longer, but you can adjust that by the global error that you include at the end. But it doesn't really matter whether or not you use MDS, physical order. For me, in roses, the QTLs that show up are in the same spots. There's basically three methods. They all agree. So it's just, I guess it's to this point, it's almost preference of what you want to use and what you want to learn. Ideally, you would run Map Poly, you would run Polymapper, and you would run Poly Origin, and ideally run the Poly QTLR, you would run QTL Poly, and you run .qtl, and you're going to get the same results, ideally. And that's what we've done with our rose data, and so far they agree on the big picture. All the major QTLs show up where in the same places, and I guess we'll talk more about that in the January meeting of like markers, like statistics of, oh, this map versus this map, stuff like that. But generally, yeah, they all give they give similar results. And me and Chris were having this conversation the other day that while the maps are different in size, really the order doesn't matter. I did correlations between Polymapper maps and Map Poly maps. And while one may be like 100 centimorgans and another might be 150 or 200 centimorgans, when you compare them together, their Pearson correlation is 99% to 1. So the ordering is exactly the same. It's just how they estimate the centimorgan length. So it's not going to affect your QTL scans of where it is, because in the future, centimorgan doesn't really mean anything on the global scale. You're going to refer back to your physical position on your reference genome anyways. So centimorgan really doesn't matter in the big picture. It's only relevant to your map, to your how you run your map, which program you use to run your map, and your population. It's not going to translate over into the next map. There's a question on what types of markers can these programs deal with. I am not sure about poly origin. I think that can only take dosage. Correct me if I'm wrong, Maria. You might know more about poly origin. I think poly origin can only take dosage. But MapPoly and PolyMapper can either take dosage as discrete 0, 1, 2, 3, 4, 5, 6, whatever your ploidy is, or it can take probabilities of certain genotypes. And their vignettes kind of describe how to input those. And I haven't had probabilities to play around with yet, so I haven't tried myself, but soon we should get probabilities. Any other, are there some
I have
other
a question
questions?
for Gabriel and others that might know is whether or not we're gonna have the ability to map multi-allelic type markers in addition to SNPs, which are biallelic.
Just
Yeah.
before I forget, for polyorigin, you can use the SNP data and GBS data too. So it's open to both markers or GBS data.
But I think just to complement that, Maria, is just like polyorigin only takes dosages, right? It doesn't work with probabilities, right?
I don't think so. No, it will take dosage.
Okay. So answering Oscar's question, so we are working on the expansion of MapPoly, and both MapPoly and QTL Poly to deal with multi-allelic markers. It means like we can use any type of multi-allelic and any level of information. Like you can have, like, for example, in a tetraploid, you can have up to 8 alleles possibly, right? For a given biparental cross. So we will be able to work with any level of informativeness in this range, like since the biallelic up to the 8 alleles in the case of a tetraploid, or 12 alleles in the case of an hexaploid. So it may be available soon. Yeah. Mm-hmm. And it will also accept haplotype data. Mm-hmm.
I have a question. With respect to development of all this software, you're assuming an auto polyploid. What happens if you have a messy situation where you get a lot of preferential and some non-preferential pairing? How does that mess up your mapping? Or does it?
Yeah.
So
yeah. Go ahead.
Go ahead. That's another difference between MapPoly and PolyMapper. Right now, I guess the stable version of MapPoly isn't able to deal with any preferential pairing. PolyMapper is able to detect where there is preferential pairing and adjust the map at that position for preferential pairing. There's, in the vignette at the very bottom, there's kind of a little blurb about how to do that. And in my populations, both my populations each had one chromosome that had a little bit of preferential pairing on the ends of 2 different chromosomes. And it's just a few steps, and it just shrinks the map by maybe 1 or 2 centimorgans. It doesn't really affect it much, but PolyMapper right now can kind of account for it. And I guess in the future, maybe MapPoly will be able to account for it. I don't know. I can't speak for Gabriel.
Yeah, just to complement that, you can, yeah, you're right. So MapPoly doesn't actually takes it into account when modeling the phenomena, right? But it can detect. So we have detected preferential pairing in some species, but when we are able to do that when the preferential pairing is not high, it's not super high, you know. But when it's super high, we may expect a distortion on the segregation rates, and those markers would be removed from the data set. Like assuming that the user is following the tutorial or the main pipeline of the software. So that may happen, and we are aware of that and working on a way to avoid this kind of problem. But yeah, it can detect you. Yeah.
Somebody's asking whether now we can explain a graph of preferential pairing.
Okay, so answering Dongyang's question, this is the output, at least for MapPoly, this is the output of the preferential pairing. So just briefly, this is the output of a preferential pairing graphic based on a tetraploid potato data set. It's a real data set. And here, the dashed line shows the expected proportion or the expected probability of a given any given configuration of phases during the meiosis. So here we have the probabilities in the color lines represents the probability for each one of the linkage groups and each one of the haplotype pairs for each one of the parents, right? So as you can see, we have like three possible configurations for each one of the parents. And this is conditional on the ploidy level, right? So for each ploidy level, we will have one expected probability, assuming that we don't have preferential pairing, okay? We have like random pairing. And we can marginalize this probability after getting the genotype probability given the map. Like after the HMM chain and everything, we can have the probabilities for each one of the genotypes on the progeny and for the parents given the known phase. And we marginalize that and we can calculate the probability of each one of the possible phases for each one of these chromosomes. And based on that, we can detect the possibility of a preferential pairing or not. That's what I said. If we have markers that were not eliminated during the segregation test, we can detect them here because the map, the HMM model is general and robust enough to capture this kind of pattern. So okay. If we had, go ahead, Doug.
So yeah. So do you, I mean, like we can interpret this graph as like if all the like different kinds of chromosome pairing when they are parent is like close to the standard line, here is like a 0.25. That means there's no preferential pairing.
This
if
exactly.
There are, it would be the colored lines would be farther away from the dashed line.
Yes, they would like
okay.
they would be drawn here, for example. They would be like very far away from the dashed line.
Okay. How about the ones like a particular chromosome combination, like the tails like far away, and then the other tail is on the other, you know, the tails are far away from the dashed line, but the middle is kind of like lining up with the dashed line.
Like, do you mean a situation like this, for example, like this red one here?
Yes, or even further away from the dashed line.
Yes, so this one, you know, so that's why we have the test here on the second graph, because we can test for each one of the positions, considering each one of the pairing of the pairs that are possible here. And if we have like a test that goes up to a given threshold, we can assume that this region have preferential pairing. Okay.
Okay.
So yeah, that's why we have this test here, because you know, just by looking here, we cannot like tell if this is real or not. This is statistically significant or not. Okay. Yeah. So but what we have seen so far is that when you have a given configuration that presents preferential pairing, the whole line is above the threshold here. So they are very far away from the dashed line, you know. Yeah. So this changes, like they may probably be only fluctuations on the sampling population, you know, like due to the sampling, due to the small number of individuals in the population. For this population, we have less than 150 individuals. So it's a kind of a small population, a medium to small size population. So it's prone to sampling errors too, or sampling bias. Okay.
Okay, gotcha. Thanks.
You're welcome. Just going further with another question here. If the softwares can deal with allopolyploids, so maybe so actually allopolyploids, if you have allopolyploids where each one of the subgenomes or each one of the partial genomes have only 2 copies, maybe you can think about treating them as a diploid, because the segregation, the expected segregation rate and everything that applies to it may follow the diploid models and the diploid expected probabilities and everything. But if you have an allopolyploidy level where a given subgenome has more than 2 copies, like 4, or you have a subgenome with a tetraploid level, it may be a good idea to divide in subgenomes and treat each one of the subgenomes as an autopolyploid, right? So this way you can capture the correct pattern of this species. I don't know if you, Jigging or Chris or Maria, you have any thoughts on that? But that's the way we have been working so far here.
I think a thing that also needs to be noted that this software works really well with diploids. And we talk about polyploids all the time, but sometimes mapping highly heterozygous diploids can be a real issue with the standard software used in agronomic crops, because they're used to selfing and things like that. And so this software is particularly well designed for that sort of highly heterozygous parental type situation.
Yes, that's a good point, Dave. So I'm, maybe Jigging can answer that better, because I don't have much experience with Polymapper and Polyorigin, but MapPoly works with diploids as well. So you can build the complete, you can go through the complete pipeline of the software, considering any diploid species. The only exception would be for designs like mating designs where you have inbreeding and everything. So you may need to adjust some things before running on it. But Marcelo and Xiaobang Zhang have run analysis for maize and also considering inbred lines with some adjustments. So this may be possible in the other softwares too. Do you know anything about that, Jigging? About the other softwares?
We have mapped diploid roses in Polymapper, and because it was joint map was taking way too long. And I don't know about Polyorigin. I think it can do diploid also.
No, actually, so
Polyorigin
was built for polyploids, but the same Chelsea, the same author, he had a previous software name is Rabbit, and that is run actually in Mathematica, and that is for diploids. The same haplotype reconstruction, but the name is Rabbit in case somebody here is interested.
Yeah, just to complement that, we have run, I remember now, we have run some analysis on a diploid biparental population of sweet potato, of a diploid species of sweet potato. Yeah, and of course we run that only on MapPoly, but it worked well. Yeah, the map is really dense and we could map QTLs and everything. So Ira has a question here. Maybe this question is for you, Jigging. So for example, I work with Blueberry, which is an obligate outcrosser. I have sets of populations made through half-sibs crosses of diploids. Polymapper should work for that?
I think so, if I'm understanding the question. obligate crosshair have sets of populations made through half-sim crosses. I think it should work.
Yes. Like just to make sure, Ira, you mean like performing the analysis inside each one of the populations, or considering the population, all the populations together? Because if you are trying to consider many populations, like multi-parental populations, I don't think Polymapper can do this yet.
No.
Yeah. But for a biparental cross, if you consider
biparental crosses,
biparental crosses, both should work, Polymapper and MapPoly. Yeah.
If they've got a genome and they've got a genetic map for blueberry, then they might be able to use polyorigin and diaqtl to do the joint analysis.
Yeah, Roseanne mentioned that she was struggling with the SMAP, right? Yeah, both Polymapper and MapPoly can do that for outcrossing populations. There is another question here, but I think that Jigging pretty covered everything about that. About the usage of MDS or the physical order of markers when you have the genomic information. So as far as I understood, as far as I got, Polymapper doesn't allow the user to enter genomic information. So you need to make the decision of grouping and ordering based on the 2-point fraction recombination fraction estimates, right?
Mm-hmm. Yeah.
Okay. Mm-hmm. Okay.
Or I guess you could theoretically group with the physical order outside of outside of Polymapper, and feed it in and force MDS, but it would be really similar to just doing that inside of MapPoly.
Okay. Yeah, you mean like manipulating the data so you can put a priority order. Okay.
But it wouldn't tell you anything about, it can't use any sequence position information. It could only do that on a grouping level.
Mm-hmm. Mm-hmm.
And it wouldn't be able to group any homologs, because one big thing about Polymapper is it wants to group the simplex by nulliplex chromosomes, and then it wants to know where the homologs are.
Mm-hmm.
And before it does all the mapping. Yeah. So yeah, that might be a little hard, because you wouldn't be able to group the homologs. You could only get the chromosomes. So yeah, you would only have to, if you have genome information that you want to use, then MapPoly.
Yeah, great. So as far as I am aware of, because I have been working with Marcelo on the implementation of those functions for grouping and ordering. And MapPoly you can use the genomic information. You can use the 2-point recombination fraction estimates. And for the grouping part, if I'm not wrong, you can use the combined information, like you can set groups. Yeah, the intersection. Yeah, that's correct. Like you can form groups that agree both on genomic information and on the 2-point fraction. Okay.
The new question that just came in and said, how can we use those for sugarcane having very high polyploidy and heterozygosity? Doesn't sugarcane jump ploidies too? Can it from generation to generation kind of jump or gain?
Yeah, I know that the ploidy level can change between groups and individuals. I'm not sure the pattern, if there is a pattern.
Yeah, I'm pretty sure Marcelo has worked quite a bit with sugarcane. It'd be good to have him here, but there's a lot of aneuploidy going on too, so it gets kind of messy.
I recall Marcelo saying he's not going back to sugarcane. No way.
Yeah, this is the most complex polyploid, I think.
Yeah.
Yeah. in my previous lab, we started to work on a collaboration with sugarcane. And I remember there was this phenomena where you have like different homology groups with different ploidy levels. Like you can have a group with a tetraploid level and another one with a decaploid and octaploid and everything. So yeah, our approach was to try to build each one of the chromosomes separately. So we would need to figure it out first the ploidy level, then building each one of the chromosomes separately, considering different ploidy levels. But you need, you know, you may know that you may need a very high read depth for GBS to capture and to correctly estimate the genotypes for individuals in a decaploid level, for example. This is pretty hard.
How common are double recombinations and how does that affect the mapping?
Jigging, would you like to say something about that?
Yeah, double recombinations happen, but mapping it really, there's no advantage of mapping it, or there's no advantage of, you don't gain anything from besides knowing where they are. Now, there is like Maria was saying earlier, with DocuTL, with the polyorigin DocuTL, you can find those products. You can find ends of chromosomes that have 2 copies, and we've done that before in Rosas, where we find maybe a QTL is on the end of a chromosome. Then you go look for things that should have segregated simplex and nullplex, and you have individuals that have 2 copies. It's like, oh, that's great. Now you can use that to breed, and now you're going to have a lot more individuals in your population that at least have 1 copy. So you can isolate those in polyorigin and DocuTL, but MapPoly and PolyMapper, double recombination is something that is not in the, I guess, assumptions. So those markers are filtered out. So you won't even see those in those 2 mapping software because it's not in the assumptions. It's not a possible assumption.
Yeah, just like you mentioned, in polyorigin, you are able, when you see the map of the haplotypes generated, you can clearly see where there was a recombination event. And just like he mentioned, if there are 2 recombinations, you will see that there too. So there is a possibility to account for that. And just like I said before, double reduction and other events that you could see in polyploids. So that is the advantage, I guess, for the haplotype reconstruction. But that depends on the crop, right? Most crops will have regularly just 1 recombination event, but if the crop tends to have more than 1, I think that will be very valuable.
Yeah, we have discussed about this double recombinations in some situations here, and we have chosen to not extend MapPoly or one of the softwares to deal with that for now, because we are aware that the expected rate of double DR occurrence is pretty low, and that would increase a lot in the HMM chain. So, for example, in a tetraploid, we have 36 states for each one of the positions in the map. And if we remove the assumption of no double recombinations, double reduction, we raise this number from 36 to 100. And for hexaploids, we have 400 states. We would raise this for more than 2,000 states. So the chain would need to visit one of these states for each one of the positions in the map. And the recombination, the multi-point recalculation would be cumbersome. That would be very difficult and very resource demanding. So that's why we have chosen to keep assuming that the DR does not occur. But this is something, this would be easy to do, but we would need powerful machines to construct the maps. That's why we kept them away for now.
The other important point Jigging mentioned is if you're mapping, eventually using this data to map some traits, it's good to know if the region where your trait has a link marker is in a recombination hotspot, or if it's far from it. So that definitely will help you make decisions, especially for breeding.
In the development of MapPoly and Poly MapR, it was all based on biparental populations. Are you all working on trying to get multi-parental populations or interrelated populations into these programs to make it a little more powerful?
So
yes.
Yeah. Currently, PolyOrigin use multi-parental populations that are interconnected. I think one of the best examples there is the partial diallel population, where the populations share at least one of the parents with the rest of the interconnected families, and it takes advantage of that to reconstruct the haplotypes.
Yeah, on the diploid level, there's a program called FlexQTL, which can deal with multi-parental, interrelated, multi-generational type situations, which tends to be quite powerful, though it's real difficult cleaning the data to the point where it actually works, because it's very demanding on data quality. Let me just put one general question out there. I know you dealt with it a little concerning the number of markers you need per chromosome, but the question I always think about and always hear people ask is, how big a population do you need for a tetraploid, a hexaploid, octoploid? Well, most of the crops we deal with are actually tetraploid among these polyploids, but there are others. But, you know, you previously mentioned, you know, well, 200, that's a good sized population for a map. But at that, when you have 200 individuals, what kind of, I guess, accuracy can you expect? You know, down to 1 centimorgan, or, a chromosome should be what, about 100 centimorgans theoretically. So if you have 1 marker per centimorgan, well, you only need 100 markers, right?
For a diploid. For a diploid, 100.
Okay, and for a tetraploid?
I think we shoot for 200, but sometimes that doesn't, we can't get that many individuals, at least in our crop.
Yeah.
So with my maps, I have 160 in one population and 200 in another. So they made okay maps, and I'm thinking that Roseanne, that has like 220 something, she should be able to end up with a pretty good map with 200, over 200, theoretically. And it goes up from there. I don't know, hexaploid, would you want 300 or more? I don't know, Gabriel.
Yeah. It's difficult to to come up with a magic number, because it depends on many things, but overall we say like 300 is a good population size for hexaploids. For the sweet potato population that they see, not one population, but all the biparental populations that we have been working here at NC State, they have more than 300. But the 300 is like the minimum number to get a reliable linkage map. Yeah. Assuming that we have a good read depth, a good reference genome, and a good marker density as well. Yeah.
So if you don't have a reference genome, would you need, I guess, greater population size?
Yes, but more than that, I would say we would need a better protocol for getting the genotype information. Like a higher, if you're considering GBS, I would consider like a very high read depth, because when you don't have a reference genome, maybe Chris can say more about that. But when you don't have a reference genome, you would need to make use of close related species reference genomes, or use the de novo alignment or de novo assembly. So you would need to have reliable sequence data to do that. So Chris, do you have any thoughts on that?
So we have two ways of calling SNPs, I think. One's with Tassel, de novo, and other is with stacks. But both of them, they would work better if you use a closed species genome than just with de novo. And so it's will not be too efficient. And so you need to, some people use several genomes to call, like several related genomes, and take the markers that are consensus between them, or something like that, that works better than if you use de novo approaches.
One comment that I like to make, I think, with respect to the questions on resolution that Dave was asking, is I think it all boils down to what level of resolution you're trying to achieve in your mapping population. You want to have a map that is within a centimorgan resolution, a map that is within 0.1 centimorgans or 0.01, right? So that defines the size of the population that you need, because with 100 individuals, if you detect one recombinant out of those, that's about close to a centimorgan. And again, you want to see that recombination more than once, or some of the software will kick out that marker as thinking it's a genotyping error, and so forth. So it really depends what resolution you want for your map. And then the next question is what size of a population you can practically manage to get the adequate phenotyping to also get some good QTL scans performed down the line. How much accuracy do you want to have as to the position where the QTL lies, and how close you want to be to the gene underlining that QTL, for example. So yeah, there are a lot of questions to ask, and it all depends what in the end is the purpose of the linkage map exercise and the QTL analysis down the line as well. And number of markers is more of a function of the number of chromosomes than the size of the maps that you get in the end.
Okay, well, I guess this is the end of the session. Thank you very much. I think it was very good discussion. I appreciate all the questions, and looking forward for the next meeting in a week.